So we are trying to learn a technology, right? But before we try to know a bit of DevOps and we start working with DevOps tools. Just to give you a quick wrap up of how most of the things work in this industry and what are the components that make up the infra of this DevOps and any other IT infrastructure, right? So how does that start, right? So we basically tend to uh, work on the end goal of S SLDC or SDLC, software development life cycle. So any work that is getting done mostly in our uh, IT culture is generally depends on SDLC or software development life cycle. Means we have a end goal in mind for or a end product in mind where we want to uh, use that or develop that product so that it gets used by consumers like us, maybe end consumers who can use those products for their own to solve their own problems, right? So this is on a very generic or high level objective that we follow in any IT infrastructure, and all the other umbrellas get set up to support this mechanism of software development life cycle, be it the DevOps team, be it the testing team, be it the network engineering team, be it the development team, and any sort of teams, right? So the main objective that they try to follow in most of the IT companies or IT culture is SDLC, right? Now, to have this SDLC methodology, SDLC culture in uh, integrated, right? So back in the 90s, we used to follow a method known as waterfall, right? So what is this waterfall method? As we know, or we 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 have, let's take an analogy over here, right? And then we'll understand what is waterfall method. So if you try to traverse from in your, let's say, from third floor down to the ground floor, right, of your building, what do you have to do? You have to come down from step one, step two, means from the third floor, take each step at a time, and then come down to your ground floor, right? You you take each step at a time, and then you reach your destination at the bottom of the ground floor, right? So this was basically the strategy that the team used to follow long back in the 90s uh, for developing their softwares, is that they divided each steps or they divided into their each requirements into each steps, and until and unless each step is being completed, uh, they could not, means they could not hijack that step and move into the next step, right? Like just like a water, if it falls from a third floor to ground floor, so water will traverse from the uppermost floor, and then it will take the stairs one by one, and the water will drop down to your bottom of the floor, right? So likewise, let's say if one of the team is stuck on a high floor, that until and unless that blocker is removed for that team, all the other teams that are working in that software development life cycle are always stuck, right? So this is where we faced a lot of challenge because there were a lot of dependencies for most of our teams. and at the end product, our entire business got affected, right? So every model has few advantages and disadvantages. Like for this, the advantages when they use that was it was very simple to use, right? And it is very used for much smaller projects to have a quick results. But if you go it take it on a very bigger teams like the teams now we see, right? It would have been very difficult because we have different sort of teams, maybe the development team, maybe the operations team, maybe the deployment team, maybe a number of teams, right? And if each team is dependent on some other team for their work, then our entire uh, time management and our entire business can get affected if one team is logged, right? So this is where we had moved from this model of waterfall, and we had started to take up uh, the next model known as the agile model. So this is more of a theoretical concepts, just to give you a high background of why DevOps came, right, and what are its benefits, just to get you yourselves familiarized with those techniques, right, or those uh, terminologies that we generally use in this industry related to DevOps, right? Just a quick wrap up, even if you know, I think it will rejig your brains a bit, right, to keep you familiar with this. Okay, I'll park in between to take a bit of questions again. Please do follow along for now. So the next method that we tried to we came up with is known as agile model of development. Right. So what is agile model? So agile model is one sort of model that is very much flexible. In one word, that is very much flexible in terms of software development life cycle. And we had broken those dependencies that we had for from each of our individual teams that we focused on in waterfall model, be it on the operations team, be it the deployment team, be it the development team, right? And if each team is stuck now, we have a good collaboration in this agile model, and we can get our things sorted, right? It helps in evolving or maintaining a focus on the efficient delivery of the business or the product, right? This is where agile came into the picture. And what is agile? So let's say in waterfall, we had estimated to release a feature for a product. Maybe let me take an example. Let me if Netflix we were delivering our Netflix product feature, maybe let's say HD version product to our end consumers. Let's say we would have taken 6 months as a whole. We might have estimated that time to deliver that HD product feature for our Netflix app to our end consumers. And if we are not successful due to any blockers, right, the entire business got affected in the waterfall model, and end of the day we had losses, right? But when we came to agile, we said that hey, we will release that HD feature, but we can break those down into multiple small sprints, which we call in agile terminology, that we can break them into small chunks of sprints, and we can have those uh, developed and released out to our end users, so that we do not take it a big chunk at a time, which is generally takes a longer time for the release, and our release might get affected, right? So in agile we generally take work into small 14 days to 21 days small sprints, and that made our life more easier, right? And we were able to grow fast, we were able to collaborate and communicate amongst our teams, and we were very much responsible of what are the changes that we require to make, right? So this is how agile mostly helped us in focusing on delivering our SDLC uh, in future, right? Just a quick thing, these are mostly, I am saying I might bore you for now. Just a quick uh, knowledge on how the teams are functioning right now. So in this agile, there are multiple terms that are multiple terminologies again we use for our team members. Maybe we will have a product owner who owns the product or who is the captain of the ship. Let's say for that Netflix app example. So we for that Netflix app we will have a product owner. Next we will have a one Scrum Master. So this Scrum Master will is the first person who reports to the product owner related to any uh, issues or any guidelines or any sort of contributions that is required for that Netflix app. He is the person responsible, and then under him, under the Scrum Master, we have all our team members working on that product, right? So this is on a very high level on what the structure looks like, right? So the structure is basically product owner, then Scrum Master, and then we have our team members. Yeah. So this is how basically things work, and in that, but again, this had few challenges to sort out, and that is why we moved into the culture of DevOps, right? So write that down first. DevOps. So post this, right, we moved into a strategy to again enhance our SDLC, and we moved into DevOps, right? So what is basically DevOps? It is we might think and we have a very wrong concept. Most of the people out there in the business industry or in the IT industry think that DevOps to be a one sort of tool. Maybe DevOps is Kubernetes, or maybe DevOps is Docker, maybe DevOps is GCP DevOps, maybe DevOps is some sort of a tool, right? But no, DevOps is no tool, but DevOps is basically a philosophy, right? A philosophy of collaboration between the development team as well as the operations team to enhance our software development life cycle. Yes, using multiple uh, tools to enhance that work. That those tools may be uh, our source code management tools or our configuration management tools. I'll come into what sort of tools are those, but yeah. But at the end of the day, DevOps is basically a philosophy, right? To that mostly focuses on uh, enhanced collaboration and communication between the our development team as well as the ops team. Now you might ask me that why was there no collaboration in between those teams in waterfall method? So see, this sort of collaboration what I am now talking about there, because uh, it might have been there in waterfall, but it was not much streamlined. What I mean by streamlined is, as each teams were dependent with some other teams, and like just like this, the water falls from the upper stair to the lower stairs, right? So if the teams sitting on the upper side, right, maybe the architect team is or the design team, if they have not designed the product properly and it was not tested much, then when the operations team tried to deploy or tried to uh, yes, I would say deploy and not install, means when they try to deploy the code for the users, or let's say for our example, if one of the developers have developed the code, let's say our the Netflix code, and he tested that in Windows machine, right? And now when the operations team or the deployment team took that code to production and they have released that code to our end users, so maybe that code got deployed in a Linux system, right? Because there is, because the developer tested in Windows and the code got moved into a Linux system, there there can be more many issues which the developer might not have faced in his or her testing life cycle, right? So as a result, there are issues that's coming up post our release of our Netflix app, and there is a what I would say less of collaboration and more of a blame game that falls back, right? Hey, you might have not tested the code in this sort of environment, or he might come that the ops team that you did not tell me what are your exact requirements or where are you deploying your code, right? So these sort of challenges came over there. But in DevOps, because it is a philosophy of more concentrated on collaboration and communication between the development team and the operations team. We have such things more streamlined and automated, I would say, so that these these sort of challenges are never faced uh, in 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 our near future when we are working in this SDLC process, right? So this is basically DevOps. What is DevOps? DevOps is, again, I would repeat, DevOps is a philosophy and not any particular tool. Yes, DevOps uses few tools to have its processes streamlined, and we will come to most of the tools and what are those tools, and we will learn in depth on those all the tools. Any questions up till now? Uh, or else I will move on. Hello, no questions?
Okay.
Okay, fair enough. I guess yes, these things you might be knowing if you had already been working. So just a quick rejig of of what we know, and at least to have our base concepts clear, right? Yeah, fine. So this DevOps, again, we have I would say broken down it into three key aspects. So what one stands for CI, one stands for CD, and again there is another CD, right? So what is this first CI? This first CI is stands for Continuous integration. What does this CD stands for? Straw.io is giving a lot of trouble. That's fine. Continuous delivery. And what does this stand for? I'll explain each one. Bear with me. Continuous deployment. Okay. So again, DevOps is mostly we understand what is mostly DevOps, and again, DevOps has broken down into uh, three major aspects. One is continuous integration. The second would be continuous deployment, I would say, and the third as a whole is continuous delivery, right? So let's understand what is continuous integration first. So if I go with a very logical definition, so it is basically a practice of automating the integration of code changes from maybe multiple developers into a single project, right? So what do I mean by that? I mean, let's say in if DevOps was not there, someone you all understand what is a developer, what is a tester, at least on a high level on those things, who is a deployment engineer and operations engineers. Put a quick +1 in the chat if you are sure on that. Otherwise, I can once again take a quick one-liner. Yes, no, maybe. Anyone? Okay. Then I hope you are aware of that. Fine. So what used to happen earlier was someone was developing the code, then he passed that code to some the next team to build that code. Maybe if he is working on a Java based code development, so a jar file. So to release that, right, we have to package or build that together in form of a jar file that is generally used for Java based applications. So some other team was building that jar file, then he used to pass that to the our testing team to get that code tested, and then this process was very much a manual work, right? And if any process is stuck, so again he has to come back to the base developer who has developed the product, and our processes got delayed. So what this continuous integration method tells us is it allows the developer to au- automatically integrate or may check his code with the help of the testing and the build in an automated way, right? So that there is no time delay in moving the code to multiple different teams and then coming back with a feedback, right? So in that way, continuous integration works. Let's say the developer is pushing his code automatically. At that same point of time, his code will get picked up, his code will get tested, and then his code will get built, and he can also check his code if his code got successfully built or it did not pass the test, right? So he gets the entire process at one point of time, right? So this is what mostly continuous integration means. Yes, there are multiple tools that facilitate that. I'll come to that, but yeah. The next is continuous deployment. So people get a bit confused on this what is continuous between continuous deployment and continuous delivery. So if I go with again a high level English definitions are, so continuous deployment is a software release process that uses automated testing to validate if the code base are correct and stable for immediate deployment to lower level environments. So what I mean by that, let's say uh, my developer has now built a code, right, and it is mostly tested. But how does that code perform in your lower level environments? What do I mean by lower level environments? Is let's say before taking that Netflix app and putting it into the App Store or Play Store for our end users to use, we need to test that code in my lower environments, be it the development environment. We name in this sort development environment, testing environment, or stage environment, right? So that we do not face that problem that I discussed back, right? My developer might have tested or built the code on Windows, and we are trying to deploy that in production on Linux, right? So to overcome those sort of challenges, we tend to deploy our code, what the developer has built in our lower environments, and then test the code rigorously over there, right? Be it on the load, be it how it is performing, if there is any uh, post release or post any changes that breaks the code post deployment, and all of those are tested, right? And the final uh, process is known as the continuous delivery, right? So what is continuous delivery? Continuous delivery is basically, if I it's an end-to-end process, right? Right from taking the code where it is built to directly taking that code to release it to our end users for their own use is known as continuous delivery. And why in every step I'm mentioning continuous? Because we will have all of this automated via maybe some tools, maybe some orchestration tools we call, maybe that be Jenkins or maybe GitHub or Azure DevOps or maybe GCP DevOps. We will have this automated so that there is no manual intervention that is required in each of following each of these processes. So that is, and it can run seamlessly, right? So that is why we continue. I mean, we generally tend to use the term continuous, right? So this is what we generally have the three main broader aspect, CI, CD, and again CD getting subdivided into two parts: continuous deployment and continuous delivery. Right now, let's look at a proper DevOps life cycle on a high level, how it generally looks like, and we will discuss few tools based on that, right? So first comes our planning stage, right? What is planning stage? Planning is what work we need to do. So yes, one more thing. So for now in modern industry where we are working, so basic now DevOps is aligned together with agile methodologies. So we can follow both. So agile comes with its own benefits, like taking the development life cycle into small sprints, as I told you, right, into small chunks of features, and then multiple teams are working on different features, and we take that together at the end, right? So what we need to do is first plan, right? Plan out, let's say I want to take that HD feature, that so we need to have a plan and proper set of tasks to be defined, and is required to be done, and then we the developers start to code, right? They start to write their code to facilitate that feature, right? The next step would be commit. What is commit? So once the developer has written his or her code, he needs to save that code globally at a place where all other contributors or all other team members are able to see that code, and also if required they can work on top of his or her code, right? So that is where we generally commit or use the SCM tools, the source code management tools, be it Git for local and GitHub for remote, or GitHub, and we have multiple n number of source code management tools in the market, right? So that is where this SCM tools come into the picture. The next step would be build. Just like I was giving you that example, if the code has been written in Java, maybe we need to package that code together, right? So that it gets utilized and it can get deployed, it can be further passed along and and get deployed. Why, you might ask me, why we need to build that code, right? Because you cannot give uh, your end users the code that you have written, right? Maybe I had written a Java code and I cannot give that Java code maybe to the Netflix end users, maybe if to you, right? Or to us directly on the Play Store, right? Because we might not understand Java and we might not know how to use that code, right? That's part one. Part two, maybe for security reasons, if I keep on continuously releasing my code, someone might make a duplicate copy of that code and might name it for themselves, right? So we do not generally give the code out directly. So that is the reason what we do is we try to package that code, means build it into a build it into a, for an example, let's take it, we combine that code together and build a package out of it. That is the process what we name it, call it as build process. Maybe we can use multiple tools over here based on our requirement. Maven is one of the most used tools. We have Gradle, we have, and this build tools we utilize it on this step, right? Next, we move into a test phase where we, as I told you, post our build, we need to rigorously test our code, right? So these sort of testings are generally performed by our test engineers. They write the test cases, be it manual or automated test cases they run, and we run those different forms of testing, be it integration testing or unit testing or functional sort of testing, and those are done in this step, and then we move along and deploy our deploy in lower envs, right? So in this step we can use like Selenium, and this sort of tools are mostly used. You might ask me, hey, again we need to learn this writing unit test cases or performance testing. I would not suggest that we need to learn each and everything, but we as DevOps engineers, if you are working, our main job would be to help those test engineers integrate that with into our continuous CI and CD process, right? To help them have those stages implemented in our DevOps pipelines. Or I'll come to that, right? What is pipelines and all, but we need to help them have that integration into our these different stages, right? So next is deploy it in lower environments. As I told you, before we take any code to production for our end users to use, before they use, we need to test those into our deploying those into lower level environments. We need to test that, right? So next stage, this is where we can use Docker and Kubernetes and Ansible and Terraform again to build the infrastructure and go for the deployments, right? We these sort of tools are used in this part, right? Next comes testing and monitoring, right? So as post deployment, I was telling you, we need to test and monitor the entire phase, whatever we have deployed. So we can use our quality testing or our load testing, right? How much load this can have, and how does it perform when it has high traffic hitting that. And also we can monitor it with using multiple tools out there, right? Be it Prometheus, Grafana, or there are cloud monitoring tools also there, right? Next, we deploy that in production, and we finally release the product, right? So this is generally on how the entire stages work in our DevOps life cycle. So the plan, the code commit, build, and test forms my continuous integration part. The deploy in lower environments and testing and monitoring becomes my continuous deployment part, and taking the code from directly from the scratch and releasing the code down to the end users falls under the continuous delivery, right? That's the entire end goal that we have. So I hope now this small concepts are clear to you guys, right? You might not have any doubts on these terminologies and topics that mostly uh, we hear in our IT industry, right? Any doubts, guys? Any doubts? Yes, no, maybe. Okay, let me move along then. You do not have any doubts. Fine. So the next process or the next part, what we need to look into is there are different sort of services. Okay, now before I go to that, right, let's understand one more thing. Okay, along with DevOps, now we have another very most used or very most yes, I would say used service that has come along hand in hand with DevOps is known as cloud, right? So another most important tool that or important service that we now see along with DevOps is cloud. So why cloud, right? Again, so to have this cloud getting used in our industry, it gives us very big advantages, right? Right from our planning stage or right from our design stage, what we used to have earlier, cloud has just changed the entire plethora of the work what that we did earlier. Just to give you a quick example once before I go to the main the technical terms, right? So let's say in my older days, if I had to host an application, so I have to make a plan, right? How many servers do I? Okay, let me not take it so much complex. So let's say you want to buy a laptop, right? Based on some software development requirement that you have maybe in your office or maybe in your back in your college days, right? So first things first, you need to think of your work, what you need to perform. Then you thought of, okay, according to my work, what is the specification of the laptop or the desktop I require to, if do I require a 8 vCPU or a 16 G memory, do I need to have a graphics card, and all of those sort of infrastructure related decisions we need to take, right, based on our use case. So likewise, in our companies also, they require to make those decisions. How many servers do we require, and what would be the CPU, what would be the memory, and then they used to set those entire infrastructure up, right? Now let's say they were not, by somehow they were not able to gauge their work in work, right? And what would happen if there is a pitfall, right, and they require more servers, then it means that there is time lost again, and they have to again go back to base zero, and again then do a quick redesign, and then again buy those servers and then set those up, right? So to go away with all those of hassles that we faced earlier, so cloud has come into the picture. Cloud services, I would say, has come into the picture, where they say you, okay, you don't have to buy anything from the very scratch. What I can give you is I can give you a renting model where you can come to me, rent out whatever requirements you have, pay me only for what you used, and once you're done using, you can just go off. You do not have to pay, right? So these models were very much uh, I would say favorite to our stakeholders, and it means helped us in lot of uh, possible ways, right? Maybe with our earlier method, again, if design was one of the problem, let's say if one of those use cases went off, right, and we started to work on maybe some other new use cases. So in that scenarios, what would have happened of those uh, materials that we bought for those use case related, right? Those went again for a toss, right? Our entire business capital got stuck. But here again in this cloud sort of side, these are again well catered, right? So cost was very much uh, well catered to, I would say, and when we started using cloud. That's one aspect. Cloud again comes with some other bigger aspects. We let me discuss on those. So maybe on-demand delivery, rapid scalability, and broad network access. These are the three major key features that cloud provides us. We already talked about one is cost and go pay as you go model, right? You can rent whatever you like, you use it, and then you can get done with that. The second would be on-demand delivery. Is that again falls along with whatever I told you related to pay as you go. So whenever you have a demand, you take that resource from them, use that, and you would be done with that. Next is rapid scalability. So just in my previous example, right, I was trying to help you understand on that scalability part, right? How difficult it was to scale back in our old days, right? So we had to again go out and buy and all of those things. But here in cloud, scalability is very fast, right? Because with one click you can increase, and with one click you can decrease the entire infrastructure capacity that you have. And the other is broad network access. Only buying those servers back in those days did not solve the problem, right? You need to set those servers up and using switches, routers, set up the firewalls, and all of those tasks, right? But here, because cloud is so much diversified and situated in it as a global service, right? So it has a very big, broader network. Be it on means what I mean by broader network is it is because we have a fair idea. So I am using terms now uh, that it is widespread into multiple regions, and then again regions are broken down into availability zones, and then into uh, what I can say. Yes, this into, let's say, in India, again in India, if India is a zone region for them, then again they have subdivided that region into multiple zones, right? Maybe Delhi, Mumbai, Hyderabad, so that they have a high disaster recovery as well as a high availability, right? So if one of the zone goes down, they can fall their load into some other zone in that region. So yeah, this is how and they had helped us with cloud services, and the major players that are taking a part in this is AWS, Azure, and GCP. Before I leave you for the day, there is one more thing that we need to understand. That is, these cloud services are again separated or mostly broken down into three aspects. maybe IaaS, PaaS, SaaS. So what is IaaS, PaaS, and SaaS? So it generally stands for infrastructure as a service. Because I told you cloud provides us with various services. So one would be infrastructure as a service, the second would be platform as a service, and the third would be the software as a service. So you might ask me, hey, what is the difference between these services? Fair enough, good question, if that is coming to your mind. So for that, we need to understand. We did learn this long time back, maybe in our college days or in our school days. Just to give you again a heads up, is we used to have a OSI model, right, or open systems interconnect. OSI, open systems interconnect, right? OSI model. We know of this, right? So this will generally help us to differentiate between these sort of services that cloud is now providing us. Maybe we know, right? It's a bottom to top approach. So it starts with networking, storage. What is networking? Networking is on setting up how the our traffic will flow, right, from one place to another, be it with the help of uh, switches, routers, the VNets, the subnets, and all of those. Next comes the storage, is where do we need to store our data, right? Next is the servers that we require. Next is virtualization. I think most of you are familiar with this, so I'm not going in much detail in all of this. But yeah, on a high level, that we require OS, middleware, runtime, and then the data and application, right? So it's a bottom to top approach. So this what we used to have is this networking, the storage, the servers, and the virtualization and the OS generally falls under infrastructure as a service. So maybe our VMs, those side of services are part of this IaaS, right? In GCP, we call it VMs, VMs, yes, virtual machines. As you get ready servers for your own base, be it on Linux servers or be it on Windows servers, whatever based on your criteria, you can have this entire setup done and it would be ready for you to use in some few clicks, right? Then what is PaaS? Platform as a service. So let's say you are a Java developer and you are not much sure of your infrastructure, right? You might not be sure. You might not be an infrastructure admin or you might not be a DevOps engineer, right? So you might not be have much knowledge on the platform where you need to run your code, but you know how to write your code. So what cloud is telling us, hey, you don't need to worry. I will give you that platform. You just spin that up and you give me, you deploy your code and you would be ready to run, right? So extending up till OS plus the middleware and runtime is also given, and they fall together to provide us the PaaS service. Generic examples can be, if I hear someone coming from the Azure domain, so maybe Azure web app service is one, right? In GCP, GKE is one service. Cloud Run is again in GCP. Those are container based PaaS services that's a given, right? So you bring your code, you run it over here. I will help you with the infrastructure. Cloud is telling us that. What is the next then? SaaS. SaaS stands for software as a service. So in this, what it is saying, that you as an end consumer do not have to again worry about also your code, right? I will give you everything. You just need to use that application from us if you have a requirement. Maybe typical examples of SaaS products that we are now utilizing, maybe Dropbox or WhatsApp or Netflix. These are our SaaS services, right? Uh, yes, but in so now I guess you have a fair understanding of what are the generic uh, terminologies that we use in SDLC, right? And what is DevOps and all of those aspects, right? Any question, guys? I think there should be some questions that's coming to your mind. You are very much free to ask. Okay, even if I'm not stopping, you think the pace is too high, you might put those in chat or anywhere. Is I'm fine with that. But yeah, if you are mostly done for today, if you have any questions, please go ahead and ask. Okay, then I guess fair enough. If you have understood up till far, very good, guys. So that tomorrow's agenda would be we go and start researching on and learning on our tools. So we will start with Linux refresher from tomorrow. So the first part would be Linux refresher. That would be our agenda for tomorrow's learning. And then we move along. We done shell script, then learning Git and GitHub, and then the other tools that are mentioned in your syllabus, right? We will take up one by one, and then yeah, that is how we will move along in this entire course. Any question, guys? No. Okay. Fair enough. If you do not have any questions, well, a quick small request from our side is who has joined in, please do put in your email IDs as well as your contacts in the chat window. That is a bit required from our side, right? So can you please do that before we drop for today from our session? Before you drop, can you please put your email IDs and contact numbers in the chat quickly? Thank you, Chandrasekhar. What about the others? Have you already posted or uh, put a +1 if you have already done, or you can put that in the chat before you drop off? Thanks, Ramana. What about others? Vijay. Thanks, Vijay. Thanks, Shrikant. Only one person I see is left. Gopal, can you please also do that from your side? Okay, for Vijay, Ramana, and Shrikant, if you have any questions, you can ask, or else we are done for today. Maybe we reconnect back tomorrow sharp at 8 and we continue our journey of learning, right? Yep, thank you. Gopal, can you please put your details once if you are able to hear me? Okay, fine then. Thank you all. Thanks for joining in. Bye bye.